Hey everybody, and welcome back to another fun and exciting intermediate math class. In today's lesson, we're going to kind of continue the thought that we had in the last lesson about dividing polynomials, and we're going to do something called factoring polynomials. This is found on page 425 in your book, 425, and this is 10.7. 10.7. So when I say the word factoring, what do you think of when you hear the word factoring? I've actually kind of developed my own word for factoring. Look down here, and I wrote the word unmultiplying. I know that's not a word, okay? And so you might think, well, the opposite of multiplying is dividing. And you're kind of on the right track, right? But unmultiplying it's like dividing, just a little bit different. That's why I had to come up with my own word for it. So the books are going to use this word factoring, but you're going to hear me a lot of times say, we need to unmultiply this. We need to factor this. In other words, it's like the number has gone together through multiplication, right? You take two numbers, you multiply them together, and it comes out to a number. We need to undo that. We need to take that apart, okay? So let's use the number 12, for example. All right, so here's our number 12, and we want to unmultiply the number 12. Well, there's several ways that we can unmultiply the number 12. One of those ways is we could say, okay, 1 times 12, that equals 12. So this is one way. This is one way we can kind of pull it apart. Another way that we could unmultiply the number 12 is 2 times 6. That also equals 12. Okay? So again, we're pulling it apart. This is like, it's impossible to know what two numbers were multiplied together to get 12, but we can show some options over here, and we can say, oh, it could have been this, or it could have been that. And then there's one more option, and that's 3 times 4 equals 12. So those are our three options. So it's either going to be 1 times 12 or 12 times 1. That's the same thing. It could be 2 times 6, or it could be 3 times 4. All of these options right here give you the same answer. They all give you 12. That's unmultiplying. Okay, it's like taking the number and trying to pull it back apart from where you started from. Now, the difference in division is that it tells you, like it'll say divide 12 by 3. Well, then we know. Then we say, okay, this is the one right here. 3 times 4 equals 12. So when we divide that, we divide 12 by 3, we get 4, right? But the problem with factoring, with unmultiplying, is that we don't know. All we know is the number 12. That's all we know. So all we can do with that is pull out what we can. We can only do so much with it because we don't really understand. We don't have the whole problem. It's not a division problem. So when I say unmultiplying, I don't want you to think necessarily of division, but it's kind of a form of division. All right, so let's look down here. When we do this with polynomials, we're going to follow two steps right here. The first step is we're going to find the common factors. What do I mean by that? Well, you're going to have 2 or 3 or 4, however many, different parts or pieces or terms. That's the correct way to say these. So that's a term separated by a plus sign. So there's another term right here. So we have two terms. So in this case, what we want to do is we want to say, okay, so 5 and 10, what is a common factor? What is a factor that goes into both of them? All right, so basically we have to do this to each one of them, and we have to say, okay, what is the number that goes into both of those? And we want to use the greatest, the biggest common factor. And so I might even put here, we want to find the biggest, or you've heard that called the greatest common factor. So that's what we're looking for. We're looking for the biggest one that is found in both of our numbers, okay? So that's what we want to do is we want to come over here. We'll start with the numbers, and we'll say, okay, what number goes into both 5 and 10? Well, one way that you can do it, and most of you are already like, I already know the answer. Come on, pick me, right? You already got your hand raised, I know. But I'm going to take this slow. 5, what are the factors of 5? 1 times 5, and that's it. With 10, the factors are 1 times 10 and 2 times 5. So what I do is I go ahead and I say, oh, look, there's a 5 in both of those. I want the biggest common factor. So biggest is the biggest one. Common is the one that's in both of them. So the biggest one that's in both of them is the 5. So for my factors, all right, so I'm going to call it the GCF, and that stands for greatest common factor. So the number 5 is our GCF. But we're not done yet, because not only do we have numbers here, we also have letters here. So we have to find the GCF of our letters as well. So we have y squared and y. Now, sometimes this can be a little bit tricky, but what does y squared mean? That means y times y. What does y mean? Just y. So now what are we looking for? We're looking for the common, right? The greatest common. That is an important letter right there, that C. Common. That means it has to be the same. So what we want to do is we want to say, okay, we have a y in both of those. How many y's do we have in both of those? Only one. Okay, there's only one common, because look, this one only has one. So we would say that's common with that. It's the greatest one. There's only one of them. What if there was two? Then it would be y squared. There'd be two y's. Y times y is y squared. But in this case, there's only one common y. So part of our GCF is y, 5y. Okay. Now look at step number 2. We want to divide by the common factors. In other words, here's the unmultiply. We want to pull this back outside. Do you remember when we did this just a little bit ago, right? We had 5y outside, and then we had y plus 2 inside. And then we took this times this, and 5y times y equals 5y squared. And then we said, what's 5y times 2? Well, 2 times 5 is 10. And y plus nothing is y. So we got 5y squared plus 10y. Do you remember that? That was called distributing. That was just a couple lessons ago. Okay, so we took this and we distributed it in. Now, what we're doing is we're undistributing. Okay, go back up to that word. We're unmultiplying. If distributing is multiplying, then factoring is undistributing. Okay, we're unmultiplying it. So that's what's going on here. So what happens when we take the 5y out of 5y squared? Well, you could do it like this. You could divide both of these by 5y. What do you get? Here's what you get. That cancels, well, 1 and a 1. And then this cancels to a y to the 1, or just y. This cancels to a 2, this cancels to a 1, and the y's cancel themselves out. So we end up on the top, we have y, okay, so just y, plus, over here, 2. So we're going to write this over here, y plus 2. This is our answer. So you have to take both the GCF, okay? This is part of your answer. It's very important to remember that. You have the GCF and what you get when you do your unmultiplication. You have both. So what you divided by is part of the answer, and what you got when you did the division. They're both part of the answer. So this would be the answer right here. Now you might be thinking, wait a second, mind blown, because like in the last lesson, this was the question, right? See, look down here. This is the question. 5y times y plus 2. And then this was the answer. Now you're telling me that this is the question and this is the answer. What's going on? That's exactly what I'm telling you, okay? We are unmultiplying, so you're taking it once it's already been multiplied and you're undoing it. You're going back. So now you're taking your answer from a couple lessons ago, you're unmultiplying it, and then you're getting the question. Sorry, but that's what you're doing. So let's write GCF over here. because it's important that we write that. So now we're looking at 2 and 6. That's our numbers. So what is the GCF? 2 goes into 2 and 2 goes into 6. So our GCF is 2. Now notice x squared and nothing. So we do not have any letter GCF. It's just not there because it has to be common. We need it in the second one and it's not in the second one. So all we're going to do on this one is pull out that 2. We're going to divide by 2 and we're going to get what? That cancels out and we get x squared plus, and then this, what do we get here? We get 3. So this is our new answer right here. Now, how do you check this? Well, just distribute it in like you did before and see if you get the same thing. Let's see if we get back here to this where we started from. So 2 times x squared is 2x squared. 2 times 3 is 6. Look, we got the same thing that we started with. That's how we know we did it right. So if we unmultiply, and then when we distribute it back in, we get something different, we know we did something wrong. So be careful, check these, just make sure that your math is correct. And that's what we're doing, pulling numbers out, pulling the common factors out, and then to check, you are going to redistribute it back in. Let's do another one. All right, so here we go, and we want to write GCF over here. And now what we want to do is we want to take these, and we'll start with the numbers. And 2 goes into 2, and 2 goes into 14. So our GCF is going to be 2. And then we're going to look at the letters, and we're going to say, oh, look, I've got an X here and an X here. Okay. I do not have a Y in both places, so my GCF of my letters is going to be X. Now what I would say is, okay, I've got to divide everything by 2x. And what do I get? Cancel, cancel. When that happens, remember everything cancels to a 1, so I would get 1 plus, and then cancel here goes to a 1, cancel here goes to a 7, cancel, cancel, and I'm left over with a y, 7y. And that would be my answer. To check it, I would go back and say, okay, 2 times 1 is 2, x times nothing is x. 2 times 7 is 14, x times y is xy, and I got what I started with. Okay, let's do one more. And this one's going to be a big dog right here. We got 3. Ooh, can you handle 3? I think you can. So let's write GCF over here. So GCF over here, and let's look at it. We have a 6 and a 9 and a 3. A 6, a 9, and a 3. What number goes into 6, 9, and 3? Well, 3 does. 3 goes into 6, 3 goes into 9, and 3 goes into 3. All right, now let's look at the letters. So we'll start with the A's. So we'll look at A to the 5th, A to the 3rd, and A. Now let me tell you a trick about the letters. The letter is always going to be the one with the smallest exponent. Okay, it's not going to be the A to the 5th because, again, there's 5 A's in this one. A times A times A times A. There's 3 A's in this one, and there's only 1 in this one, so it has to be common. Common, common, common. In other words, there's only 1 A that's common in all of them. That's important to remember. So we have an A, 3A, and then we would do the B's. So again, I'm not going to write them out, but there's B, there's 5 B's, there's 1 B there, and there's 1 B there. So look, we have common B, 1 common B. And yes, there's 5 of them here, but only one of them counts because we only have 1 up here, and we only have 1 up here. So 3AB. All right, let's get rid of all this stuff down here. And so let's divide by our 3AB. 3AB here, 3AB here, and 3AB over here. So just go through it and just divide it out, and we'll write our answer over here. So that's going to divide out to 1 and 2. This is going to divide out, that's a 1, and that's going to be A to the 4th. This is going to divide out, and this is also going to be B to the 4th. This is going to cancel to a 1. This is going to cancel to a 3. That will cancel to an a squared. And the b just cancels out to a 1, or in this case, we don't necessarily need it, but we could put the 1s there. And then we have a negative sign. These signs are important. We'll use those in just a second. This cancels out to a 1. This cancels out to a 1. Everything over here is canceling. Okay, so we're left with 1 over there. All right, so what are we left with? All right, let's rewrite this thing and kind of clean it up. So here we have a 2, an a to the 4th, and a b to the 4th. Then we have a plus sign. Then we have this up here. So 3a squared, the b's canceled, and then we have a minus sign. And then we have a 1 over here because everything else canceled. Notice everything in the denominator canceled. Everything's all 1. So technically we do have denominators of 1, but we don't need to write that, right? So there we go. There is our answer right here. So 3ab times 2 to the 4th, b to the 4th, plus 3a squared minus 1. How would we check it? We would go ahead and distribute everything back through, and I'll save us the time. It does check out if you do that. So there's the process, and hopefully that made sense to you as we went through it. Find the common factors, then divide by the common factors. Make sure that you list the common factor as part of your answer. Very important. We pulled the common factor out, so it does need to be listed as part of your answer. All right, that's all I've got for you. If you missed anything there, make sure to slide it back and watch it again, okay? We'll see you later. You have a good one. Bye-bye.